Hello. In this tutorial, I will show how to optimize the corridor that we created inside of the scaffolding structure. So the optimization works towards that the narrowest area of this corridor should not be less than 120 centimeter, because as much as we want this corridor be organic and then create this kind of visual effects due to the curved features, we also want it to be spacious because it's an entrance hall, and then we don't want to create so narrow parts that only one person can go through. So in this case, let's look at the curve proximity, which means the closest that these two curves get. That it is still okay, it's 96 centimeters, so we can basically, clicking on this proximity component, we can see which points on the curves that are the closest points. So a person can still go through this narrow area, but it is a bit less for public space. So therefore we want this to be at least 120 centimeter. However, we don't want it to be too wide, because then we lose the effect of this organic movement in here. So we need to optimize this by manually changing the sliders. Does not really work in terms of time, although it can still work if you have a lot of time to come here and then manually, for instance, change this factor to 110, and then you see we improved the proximity. However, there is another way to do it in Grasshopper, that there is a component called Galapagos, which basically process values that we select in order to hit the fitness value that is introduced in the fitness node here. So this component uses evolutionary algorithms towards finding the optimum solutions based on the fitness function that is introduced. In our case, that the most effective vector values are at the end point for the second curvature over here, and it's tangent at the end point. And the second one is this value, this slider that defines tangent at the end point of this curvature. So we can select these two sliders, and then by right-clicking on the node that is called genome, we can input the selected sliders. So this Grasshopper component is actually a unique component that works differently than any other regular one. So in a regular component, you basically click on the node and then drag, and then input to the next item. So from left to right. But in this component, Galapagos, basically if I try to input like this, it does not work. It should be done reversely. So from right, from the node of genome, right to left. So I can actually input this one as well. Or you can right click on this node and then select all the sliders in the code to be plugged in here. If you need to input all the sliders for your optimization, you can do that. But in our case, we don't need it. We just want to input the two sliders, which are more impactful on the curvatures. So basically you can just select the sliders you want to input and then right clicking and then selected sliders, and they will be automatically connected. And the fitness function is actually a mathematical calculation that has a number as a result. So in our case that we're calculating the curve proximity, this value should go to the fitness node over here. So shortly, this component takes sliders as input. It can take as many sliders as you wish. And by changing the values of the sliders, trying to find the best combination of them that hit the desired result of the fitness function. So in this case that we want to look at this value, we want it to be 120 or as close as possible. So for that I will just use this number. We can directly input this distance to fitness, but in order to be more visual, that I'm just inputting this over here, and so this is our fitness function to group. And the same logic apply to the fitness node as well. So you should always go and plug from there. So this is the number. And now we have our sliders as genomes, and our number is the fitness connected to the Galapagos component. However, that one trick, since this component will change the slider values very quickly, I wonder that I should do the optimization only on the curves, which are not directly inputted the geometry. Because while it's changing, that is changing the values of the sliders, that is actually changing the whole calculations over here, and it might be very heavy for Grasshopper or for your computer to compute. So probably it will get frozen. So a tip, you can optimize the curves separately. So that is what I will do. In that case, we will just see the curves are changing over here. So let's see. And for that, I will just copy paste this part without without this line and the title. So I just Command C and V, just drag down here. Group. Just delete this one. Delete that one and redo. So now this is a separate definition that we separate these curvature calculations and optimization, because we don't want to go the heavy calculations of these parts of Grasshopper in order to just to see the geometry changing. But yeah, what we can do, we can just use the optimized numbers in the sliders. So just for the getting closer, I will just write Galapagos and this here. So this value and that one go to genome. Should connect to genome input selected sliders, and then this number will be connected to the fitness function. And yeah, so let's double click on this component. It will open the Galapagos editor, and you see that there are parameters. So basically they are evolutionary parameters that the algorithm will use. So for instance, if this is maximize, so the algorithm work towards that, changing the sliders and trying to get the maximum proximity between these two curves. If you click this time, the evolutionary algorithms will work towards to minimize this value. You can indicate a specific value, which in our case is 120 centimeters, so you can indicate that, or you can actually indicate a threshold as well. So I will keep it like this, and then I will give runtime limit. That means that give me the best solutions in 10 minutes maybe, and then yes, then the rest can stay the same. So I will just say okay, and then I will adjust my screen a bit, because we would like to see how these curves will change over time as the sliders change. So okay, I'm just adjusting my screen. Maybe just ungroup this one. So that we can see actually both the fitness number, fitness value here in the panel, and then the sliders which are connected to the Galapagos component. Yeah, so then these three values. So this is the fitness function, basically changed based on these two values, and then we will run Galapagos now and just run it by double clicking. Gets a little bit closer. Yes. So let's run. I will just say start solver, and then it will, you see how fast the sliders are changing, and then trying to hit the value of 120, and then basically so here you see the genomes, the combinations of these two values, and yeah, so it shows the best result. So yeah, it stops at some point. So basically it creates it, the algorithm gave us 110 generations, and then you can, by click and dragging here, you can actually select genomes or solutions results, yeah, in this selected area. So let's look at some of the good results. So basically, if you go display, if you click on this, it will show the whole results, genomes, also the ones that's not so good enough, all the solutions. If you click here, it will only show top 50. If you click on this, it will show top 25, all the solutions, and then this is the top 10. So the best solutions so far. And if you go click on here, and you can reinstate it, so you see that curvatures or the slider results are changing, and then we can select the curvatures? No. And this these curvatures are changing if you reinstate, or you can reinstate these ones. Yeah, so you can basically select whichever suits you. Okay, let's select this one, or yeah, let's select this one. This is the top solution, and I hit OK, and then just use these sliders for the scaffolding geometry, for optimizing the scaffolding geometry, and then see the resulting geometry. So I'll just